Hello guys, welcome back to Java session. Today we are going to cover set interface. In the last video, we covered the list interface followed by classes which are implementing the list interface. In this particular video, we cover the classes which are implementing the set interface, right? So this set interface is also available under the util package. The entire collection framework are available under the util package. Before creating object for any predefined class, you should import the util package first. And this set interface is also extending the collection interface because it is a sub interface of the collection interface. And the elements in the set interface, they are unordered. Unordered means they are not stored in a ordered manner. And this set interface, it doesn't allow the duplicate items, whereas list will allow the duplicate items. Now the set will not allow the duplicate items. This is the one difference. The other difference is list will store the ordered set of elements, whereas set, it stores the unordered element. And here we can store only one null value in a set. And this set interface is going to be implemented by hasset and treeset. Now we are going to see the hasset and treeset classes. This is a way how we use this set interface. This is a way of creating object for the set interface. So set, you can create the set of different data types like string or int or whatever the data type which is required, you can mention here, right? I'm creating object for the hasset, right? And in the same way, you can also create object for the tree set. So do we have any difference between the hasset and tree set means? Of course, beta, I will cover in the program. Don't worry. Now, sir, what is this hasset? Why this hashing is introduced basically? First, you need to understand here, this hasset, it is also implements the set interface. All the methods of collection interface can be used by the set interface, right? And it uses the hash table for the storage. Internally, this hasset, it uses the hash table for the storage, right? Here we use the hashing technique. Sir, what is this hashing technique means? I will explain. Basically, this hashing is introduced to reduce the storage capacity. That is the purpose we introduced this hashing technique. I will explain this. And it also contains the unique elements only. It do not allow the duplicate elements, right? Yeah. So why this hashing is introduced means, basically, if you want to search an element, we use the linear search. There, the searching time the time complexity gets increased, right? It takes O of n, right? When it comes to binary search, we divide the list into based on the middle element, we divide the list and we will search the element. There, the searching time, the search complexity, time complexity will O of log n. Sir, I want to reduce more. I want to take O of 1. That in the sense, I want to find the required element in one shot. So there, can we use this linear search or binary search means? No, they doesn't work with for this O of 1, right? For that purpose, we introduce this hashing. So there, what happens? Let us assume these are all the key elements which we have. So we are going to store these elements at their indexes only. If you have 8, 8 will be stored at 8th index. 3 will be stored at 13th index. 13 will be stored at 13th index, right? This is how we are going to store the elements in that particular position only. With this, what happens? The space complexity will increase. For example, here if you see, we have only 7 elements. But whenever you want to store these 7 elements, it is taking up to 50 number of bytes because the 50 is the last element. So with this, the space complexity is getting increased. So to address this problem, what we did, so we are doing with the percentage of size. That in the sense, x percentage of size. X is nothing but the number of elements. So here the number of elements are, let's say, x is the element, any one percentage size. Let's say 8 percentile 10, that is 8 only. We will store it 8th location. 3 percentile 10, that will be stored at 3rd location, right? Here the size is the number of elements. 13 percentile 10, let's say we have the 10 elements. 13 percentile 10, 3. So sir, already in the 3rd location, we are stored 3. If we are going to store 13 again in the same position, then collision will occur. This is the problem whenever you are storing the elements in the hash table. So to resolve this, what we did, we are using a technique that is open chaining mechanism, right? What we will do there, we will start a linked list at that particular position. Whenever the next element is going to be stored in the same location, what we will do, we will start the linked list. Here you can see I'm taking the different elements 8, 3, 13, 6, 4, 10, right? 8 will be stored at 8th location because 8 percentile 10, that is 8 only, right? 3 will be stored in 3rd location, right? And when it comes to 13 percentile 10, it will become 3. So then in the 3rd location only, I need to store the 13. So what we are doing, 3 of 0 is 3, 3 of 1 is 13. If we have 23 percentile 10, that also returns 3 only. That in the sense you need to store 23 in the 3rd location only. Then in another node, you will store 23. This is how this open hashing mechanism will give the solution for the storage of elements, right? This is called as chaining technique, right? This is how we are going to store the elements in the hash table, right? Now we will see the example program for the hash set as well as tree set. This is an example for the hashing because why we are discussing this point? This hash set internally, it uses a hashing technique to store the elements. That hashing technique is nothing but hash table only, right? Now we will see the example on this hashing, right? This is an example for hash set beta. What I am trying to do, first I am trying to create a class where the class will hold the information about a book, right? Thus, a book contains the ID, name, and name of the book, author of the book, publisher of the book, and how many quantities of books you need. This is a class I'm going to create, right? For that purpose, I'm taking a parameterized constructor. I'm initializing all the instance variables in my class. Now, I'm taking one more class. Within this class, I'm taking the main method. Here you can see, this is a syntax to create the hash set. Just now we seen in our PPT, right? Hash set, what kind of, for what you want to create a hash set? Sir, I want to create hash set for a book. What book contains? Here, this is a class which we are defined. It contains the ID, name, author, publisher, and number of quantities, right? For this, I want to create the hash set. Now, what I'm doing, I'm creating an object to this book class. Sir, how many objects you are creating? Book 1, book 2, book 3. For all these 3 books, I'm passing the information. So for book, I'm creating B1 object. There, what I'm doing, I'm passing the complete details, right? Because it has this book class has the parameterized constructor. I need to pass the parameters. That is ID, author name. Let us see. There is book name, author Yashwant Kanedkar, and publisher BPB, and number of books you need 8. This is how. This is the first object B1. Same way B2 and B3. I am creating the 3 books, right? Now these 3 books I want to add to the hash set object, right? Now that you can do by using add method. Here, what I am doing, I am creating object for asset, that is set dot add of B1. I'm adding the book 1 to the set, book 2 to the set, book 3 to the set, right? Now, sir, I want to display the information which is there in this particular hash set object. Then you can display in different ways beta. Already we covered the iterator and list iterator. Here I am using the for each, right? So here for each has the syntax like for each of class reference variable. So I'm taking the book class, its reference variable, I'm taking it as B. It need to get the values from the set object, right? So that I'm using, this is a for each syntax. Now, what are the things I want to display? Book ID, book name, book author, book publisher, and book quantity. These are the elements which are going to be retrieved for every book, right? When we got the information from B1 and B2 and B3, so when we don't have some other objects in the set, then it returns false, we comes out of the block. This is a way of using the hash set. It can contain the set of other objects, right? Now, this is here. Hash set, it do not sort the elements, whereas tree set, it will sort the elements. That is only the difference between the hash set and tree set. I will show you here. if you go to the tree set is also similar to the hash set. It is also implementing the set interface, right? And internally, it is using the tree for the storage. There, that is using the hashing, that is hash table, right? Now, it contains the unique elements, same as hash set, and accessing of the elements from the tree set. This is faster compared to the hash set. Tree set, by using tree set, you can access the elements at very fast compared to hash set. Tree set will produce as a high accuracy. That means by using this, we can access bit fast. So what is the reason? Because here the tree set it stores the elements in the ascending order. So that's what we can access the elements bit fast compared to the hash set. Now, sir, can you show an example for the tree set? Of course, better 1 minute. So here you can see what I'm doing. I'm importing the required package. This is my class name main method. Now I'm creating a tree set of string type. I'm adding the different strings. Ravi, Vijay, Ravi, Ajay. Sir, you are adding a duplicate element Ravi and Ravi, right? Does it accepts? Better whenever you are adding, it will eliminate the duplicate value and it keeps only the unique value, right? Now, if you are displaying the elements, you can display the elements in the elements by using this iterator. This we covered in the last session. If you want, refer it again, right? Now I'm using while of iterator object dot hash next. If we have the element or not, if we have element, then we can display the element by using the next method, right? So this is how I'm going to access all the elements. Sir, we are given in one format and how we are going to get the output. Beta, the output will be in the sorted order. First, you will get Ajay, followed by Ravi, then Vijay. This is how the tree set will differ with the hash set. This is all about the set interface, guys. Chalo, thank you. If you want the execution, I will show you. Just a minute. I will show you the output for the tree set so that you can understand. Right? Now you can see duplicate elements are eliminated, deleted, and it is displaying the elements in the ascending order. This is the difference between hash set and reset. Chalo, guys. Thank you.